Okay, great. Oh, we already have one question from Zhuhao Luo. I've just hopefully added. So,
hello, can you hear me?
Hi, yes, I hear you. If you want to turn a video on.
Okay, so yeah, I have two questions. So the first question is, I wonder how would you handle the loop in the code, since if you don't know how many times the loop will be iterated, how would you determine how many instructions will be in the final program?
I see. So the first question is how Clara handles loops, right? So a short answer is that Clara's analysis is on a per code block base. So during the false prediction, the prediction is actually predicting the number of instructions in each code block, and then performance profiling is like another routine, right? After we get like the number of estimation on each code block, because then stick them together, and if it's a loop, then it's basically execute multiple times, and it's just a multiplier on the number of instructions.
Okay, thanks. So another question is that I wonder, have you ever encountered with any corner cases that your machine learning model may struggle to get the ideal accuracy or performance?
I see. So the question is about the reliability of the machine learning model and whether we have encountered corner cases. I think this is quite common, right? Whenever we find a corner case, what we do is that we need to kind of adapt our data synthesizer to kind of incorporate this kind of insight into the data synthesizer to make sure that the generally trained data kind of covers this kind of scenario. So it's quite common to see during the early iteration of the model. Yeah.
Okay, thank you.
Okay, we have a question from Jiarong Sun, I think.
Yes. So great work. And my question is about like how diversified of the synthesized network functions, because you mentioned that like you synthesize thousands of network function pairs from dozens of. So is it possible that the trained model is not generic enough if the synthesized pairs are not diversified? And then the trained model probably only fits the network function pairs, which are similar to the legacy ones. So is it a very concern?
I see. So the question is about whether the generalizability of the machine learning model, right? I would say that well, first of all, right? I mean, yeah, sure. We start with like dozens of SmartNIC network functions, and basically focusing on packet processing, like packet header manipulations and metadata manipulations, and some simple stable data structures. Right? This is like the pool of functionality that we currently support, and it's definitely could be a problem if you want to like expand to other types of network functions, and that will require like a lot of retraining processes in the kind of incrementally incorporate this kind of function that we encounter in the future into this kind of pipeline. So yeah, that's definitely part of the problem. And in order to make sure that it's kind of generalizable, it's need to be updated like consistently.
Okay, thank you.
Yeah, actually, I have a sort of question which relates to that. I mean, you're doing synthetic, generating synthetic test data or training data. Sorry, that's been done a lot in the real machine learning world rather than application of machine learning to offloading network functions onto SmartNICs. But it's also done for offloading machine learning onto accelerators for AI. So we have a whole bunch of accelerators like TPUs and GPUs and so on, some of which look quite similar to SmartNICs. And I wonder if you looked at any of the work in papers at NeurIPS where people have decided when and what to offload from, not from a network function, but from a machine learning application. But it might be the techniques they use to analyze the code from a machine learning app might be applicable to networking code.
I see. So yeah, I would agree that there's like a long line of work from the machine learning approach community, like deep learning communities, which is trying to use similar approach, right? If you think about TVM, right, it's kind of like a combination of problem analysis and some machine learning insight that which is a compiler tool, right? Yeah, I would definitely say we could like learn a lot of stuff from them, right? Basically how they analyze their performance and how they incorporate the problem. I think one of the motivation of Clara is really trying to have like a SmartNIC version of TVM, right? We have multiple types of network functions to begin with, from different frameworks, and we also have multiple different types of SmartNICs, right? And we are trying to do this kind of offloading like automatically without like a lot of user intervention, and potentially it could be improved by the machine learning approach, right? That's definitely one source of our inspiration.
Yeah, I was just thinking, people have done this whole analysis and you use NLP techniques, and people have done the same thing with GPT-3 being applied to code on GitHub. So it could be, if you could find enough examples of network functions available in open source repos, that you could use the same trick to kind of enhance what you've done. I mean, I'm sure you thought of that, but I think there's quite a lot of direction of travel in this kind of work. So that's pretty cool.
Okay, great presentation. Yiming is here. So if you have any questions, please raise your hand. Oh, there is one. Yeah,
hello. Hello, I'm Gaowei, and great presentation and work. I'm from Nanyang Technological University. I have two questions. The first question is, when you utilize the machine learning to do prediction, how do you avoid that the machine learning prediction results lead to the statistics error or other program error? And the second question is, machine learning is data hungry algorithm, and you utilize the data synthesis. And I want to, can you share your experience about in what cases the data synthesis will work? And these are my two questions.
Thank you, Gaowei. These are wonderful questions. I think the first question is about the reliability of the machine learning model, right? I think for the purpose of this work for Clara, right, the key goal is to predict like the network instructions for each code blocks, and in this case, right, we are just trying to make sure that the variation and the bias is within a certain range, and basically we are trying to make this kind of prediction. It doesn't have to be like 100% accurate, so that's kind of usually like a feasible like range of error. And as for the second question, the question is in which case we could actually use a data synthesizer and in which case we could not, right? I think for the case of network functions, right, if you look at the work Clara, so what we do for the data synthesizer is really that we have like a lot of data pre-processing, and we are basically focusing on the status part of the NAF while doing the data synthesizer, right? We are focusing on packet header manipulations, metadata manipulations, and compute operations. So it's like a very strictly set of possible operations. And we have like a lot of existing NAF, which is trying to do similar things. And we are trying to learn from those examples. So that's how we actually adapt our data synthesizer from state-of-the-art problem analysis tools. And that's basically saying, for a specific field, if it's, if it has like a set of characteristics, it's not really generic programs like any C++ project, right? So it has to have some kind of characteristics. And then you need to kind of carefully design the problem to make sure that the generated data is representative enough of the real world ones. So that's basically our experience.
Okay, thank you for your answer.
Thank you.
Okay, any other questions? I don't see any questions from Slack. Oh, wait, there is another one. Yes, please, GQ.
Yes. Yeah, thanks for the great talk. I'm Jay from Hong Kong U. One simple question. Can SmartNIC achieve the same functionality as conventional servers? Are there any computations that, by their very nature, cannot be offloaded to the SmartNIC?
I see. And so the question is about the capability of SmartNIC platforms. So I want to start with that different SmartNIC have very different capability. For the national that we used, it's kind of, there's a trade-off, right? It's really kind of focusing on better parallelism and is kind of sacrificing some kind of computational abilities. And for instance, it couldn't really support very complex data structures, like it doesn't really support stack and many stable data structures. So when we are doing this kind of offloading, right? If, for instance, we want to actually offload a hash table, we actually need to make a lot of adaptations to adapt to the specific hardware architecture and memory hierarchy, right? So that's basically a lot of design decisions we need to make. And as for the compute, right, for pure compute operations, I think it supports most, things that they support on x86. So that's not like the most important problem. But on the memory and API call side, there is a vast difference between platforms. So I need to take this into considerations.
Okay. Thanks for the answer. Very appreciate.
Okay. Is there any other questions? If not, I have a question. So cross-platform performance prediction or automatic suggestions of optimization, that's very cool. But why do you focus on network functions? So is there any special reason why network function code works particularly well? Or maybe click elements are very simple or stateless? So my real question actually is, can it be applied? Can Clara be applied to arbitrarily complex programs? Have you? I don't think you have tried it yet, but I just want to know your opinion.
I see. So the question is about the limitation of Clara and whether it could actually expand to other problems, right? I think the approach is, somewhat generic, but I mean the bottom line is that you need to kind of divide your problem, right? If you look at Clara, it's trying to make a distinction between different type of operations, compute instruction, memory accesses, API calls. So you need to actually understand which part is solvable using machine learning and which part is not, right? I mean, network function is like, we choose network function because it's like one of the primary use case for SmartNIC, right? That's one of its basic jobs. And I would say that, our goal at the end of the day is not really limited to click, right? We want to support like multiple types of frameworks and also multiple types of SmartNICs. That's one of the future innovation of our line of work. And I would definitely say we want to try more about this approach, this machine learning approach. For instance, we want to try that whether we could encode this kind of insight into an actual compiler and compile actually click programs into the SmartNIC directly, while we kind of improve performance during the the compiler optimizations. So yeah, that's definitely very interesting.
Okay, thank you. Is there any? Oh, there's another question. Queen Hao?
Hi.
Yeah, please.
Chen Hao from Nanyang Technological University. This is a great work. I have two questions. First is, you use several machine learning models. In the practical, have you considered this machine learning inference latency? And the second question is, this machine learning inference is based on the CPU cores on the SmartNIC itself.
Sorry, I didn't quite get the first question.
So do you need to perform the machine learning model inference during the particle the SmartNIC using? You need to use the machine learning models to generate offloading insights.
Yes.
So is there or have any using latency to machine learning inference latency?
I see. So I want to start with that. Clara is really like a static analysis tool, so we are not really doing anything at the runtime. So latency of the machine learning model is not like our focus here. I mean, it's kind of like you are doing this kind of provisions on the performance before this kind of offloading begins. So the latency of the machine learning model is not our focus here. And I think the second question, could you repeat the second question?
I understand. You need to, this is you generate this offloading inside previous before the runtime. I understand. Yeah. Thank you very much.
Yeah. And could you repeat the second question?
The second question is, I misunderstand your work. I just thought that your machine learning model will put into the SmartNIC. Thank you. I understand.
Okay, thank you. Yeah.